Okay, this is a question to do with probability. Spinner has numbers 1 to 4. The probability of skinning of 4 is 0.1. Probability of 1 is 0.6. What the first telling us is it's an unfair spinner. Probability of spinning number 2 is the same as probability of spinning a number 3. So we've got two that are the same size. Calculate the probability of spinning a number 3. So the first thing to realise is probability, the total of all probabilities must be 1. So we've got a 1, 2, 3, 4, that's my score. And the probability for it, for 1, 0.6, 2 and 3 I don't know, but 0.1. So the total here is 0.7, so I'm left with 0.3 between these two. And so quick check on the calculation. So first of all we did 1 minus 0.6 minus 0.1, and this gives the probability left for 2 and 3. Because they're the same size, so I'm going to divide it by 2, and that gives me a probability of 0.15. So if we were asked further questions to deal with what is the probability, they may say what's the probability of a 3 or 4? Well, 0.15 plus 0.1, 0.25. The probability of everything except 4. Well, it's the sum of 0.6, 0.15, 0.15, which is 0.9, or 1 minus the 0.1. That would give us 0.9 for these probabilities as well, as we can see in our table. Question 15. Think of a number, I multiply a number by 8 and subtract 66. The result is twice the number I was thinking of. What was the number I was thinking of? So I think of a number n, I multiply it by 8, so that's a10, then I subtract 66. The result is twice the number I was thinking of, so that's 2n. These two things are the same, so we can create an equation. a10 minus 66 equals 2n. Collect everything, all the n's first, move the lower number of lower coefficient n. That tends to leave you a positive term. So we're going to subtract 2n from both sides, which gives me 6n minus 66 equals 0. You probably can see the answer now anyway, but 6n, add 66 to both sides, is 66, and for me to get n, I divide both sides by 6, so n equals 11. I can do a quick check. 11 times 8 is 88. Subtract 66 is 22. And 11 times 2 is 22. Yeah, both sides of the equation work. So it equals. Moving on, question 16. Some information about A-level students. Here's some information about the students in 2002. It's a two-way table again. You've got the percentages scoring A, the number of students taking 2 exams. They want to see how many more students grade A in mathematics than in English. So we need to know what these quantities are. So if I know that 19 out of 100 of English is x over 72000, I can tell my number of English students. I'll change that to an E. So English students, flip and multiply. So my E equals 72,000 multiplied by 19 and divide by 100. Everything's been lined up as a percentage. So 100% is all students taking English, 19% is whatever this number works out as, and it says the number is 13680. Do the same thing for maths. I want to know the percentage that passed their maths with an A, which was 37 out of 100. The number of people who took the exam lines up with my 100, that's 54,000. So the maths grade A, take 54,000 to the other side and multiply by it, so 54,000 times 37, divide by 100, and we get 1,980. And I could go back and use the memories, so I could store that in memory. If I had an E, I'd use an E. And if I go to the other one and store that in memory, maths M, store. Let's check I've got the two numbers, alpha M. Is that number? Alpha E should be the English one. So if I do the subtraction of alpha M from 199 minus E, the 1368, I should get 6,300. Maths. How many more students gained a grade A in maths than in English? 6,300 more. Let's come to the last one of these. 16, 17, 18. Testing equations, seeing whether or not this value works within that equation. And to check that, you can try putting the value 17 in and see if the sum works. You do not have to solve this equation. So on the left hand side I want to know, does 14 times 17, replacing the y, minus 51, is that the same as 187 plus 4 times 17? So grab the calculator, first side 14 times 17 and subtract 51. Gives me 187, and 187 plus 4, no, they're not equal because the 187 is already there. So this is going to be bigger. This one's 187 plus 4 times 17, so clearly they can't both be the same. So the answer to that one, no. Do the same idea. Look at the equation. Is y17 a solution to this equation? So you do 3 times, and it's important that you do the 17 is squared, not 3 times 17 first. Check to see if it's the right number. So 3. Now the calculator should work this correctly now. 17 squared. 867. Let's do 867. They may be trying to test to see whether or not you put the bracket. So if you do 3 times 17 first and square that, and now we get 2601. So they're testing to see, did you put the bracket, an unnecessary bracket. This, remember BIDMAS, this happens before a multiply. So using BIDMAS, the index, the power must be done first. So we're going to do 17 squared times 3, which the calculator did for us, and gave us 867. So the answer is no to that one as well. Okay. That's question number 16. Let's do the number 18. Those following the 4 to 6 paper. The last part of this question, last two parts of this question are not done on yours. So 18. This is done for the whole of question for anyone doing 4 to 6. These two are for 5 to 7 people. Okay, why is it as simply as possible? Well, this one is like terms testing. So the number 9 cannot be combined with 3k and 5k. So the number 9 is left on its own, and we've got minus 3k's plus 5k's, minus 3 plus 5 is plus 2, and we were counting in k's. Simply as possible for this one, k squared is different to k. K squared means kk. That is different term to just k. K squared is different to k. So we get a k squared plus, so we've got the k squared. The k's again, these two are like terms, so 2k plus 4k, 2 plus 4 is 6, and they can be done as separate terms. That's the end of the 4 to 6. Let's see, we're carrying on. Combining terms by multiplication. So we've got 3 times 2 is 6. K times k is k squared. You can multiply any types of terms and they combine to create a new one. Doing the division, 9 divided by 3 is 3. K squared divided by k. If you remember the index rules, you subtract the index when you're dividing. So we've got k squared minus divided by a k to the 1. So we subtract the index to give us a k to the 1, or just k. And that's the end to all those function ones.